In our last lesson, we learned about output. We used printf to make our program talk to us, showing us the values of its variables. But this is still a one-way conversation. The program talks, but it cannot listen. What if we want to build an interactive program? What if we want to ask the user, please enter your age, and then store their answer in an integer variable? To do that, we need the other half of I/O. We need input. Welcome to Lesson 2.09. Today, we are learning the scanf function, the C language's built-in way to read formatted input from the user, usually the keyboard. This function is the direct opposite of printf. Printf prints a variable's value to the screen. Scanf scans a value from the keyboard and puts it into a variable. To use scanf correctly, you need two things: a format specifier, like %d, %f, %c, just like printf. The addressive operator, which is the most critical and most forgotten part of scanf. First, how to use scanf. With %d integers, let's build an interactive program that asks for an age. First, we need an empty box to store the answer. So, we declare a variable, integer user age. Next, it's good practice to prompt the user so they know what to do. Printf, please enter your age. Now we use scanf to listen for their input and store it. Scanf, %d, address of user age. Finally, let's print it back out to prove it worked. Printf, you are %d years old. \n, user age. Second, the most important part, the addressive operator. What is that ampersand? And why is it there? This is the single biggest point of confusion for scanf. Here's the difference. Printf, user age, only needs the value of the variable to display on the screen. Scanf needs to change the variable. It needs to know the memory address of the user age variable so it can go to that address and drop in the new value. The addressive operator means get the address of. So, scanf, %d, address of user age, is telling the program, listen for an integer and store it at the memory address of the user age variable. If you forget the ampersand, your program will crash. This is the number one mistake. Third, using scanf with %f and %c. The logic is the same for other data types. Just use the correct specifier. For float, scanf, %f, ampersand price. For char, scanf, space %c, ampersand grade. Note the space. Fourth, the critical scanf, trap with %c. Wait, why did I put a space before the %c? Scanf, space %c, ampersand grade. This is the second biggest trap. When you type an age, like 25, and hit enter, two things go into the input buffer. The number 25 and the new line character, \n, from the enter key. The scanf, %d, reads the 25, but leaves the \n behind. If your next command is scanf, %c, it will immediately read that leftover \n as the character and won't even wait for you to type a grade. The space in scanf, space %c, is a magic instruction. It tells scanf, please skip the new line and then wait for the real character. Rule: always put a leading space before %c when using scanf. This is a huge milestone. We have now completed all the fundamental concepts in Section 2. You now have all the tools you need to build real, simple programs. Variables and data types: integer, float, char, constants, const, hashtag define, operators, arithmetic, assignment, comparison, logical, and now I/O, printf, and scanf. You can now calculate, make decisions, and interact with the user. The only thing left is to practice. You don't become a programmer by watching. You become one by doing. Click on the next video to start Lesson 2.10. Exercises to practice programming thinking skills. No answers. Try to solve them on your own, and then, and only then, move on to Lesson 2.11, where we will solve them together.